Okay, now speed time curve indicates the slope of the curve will indicates acceleration and retardation values, and the slow total area of the speed time curve represent the total distance traveled by the train. Okay, now next one is simplified speed time curves. Simplified speed time curves. So simplified speed time curves. So first of all, we can draw a speed time curves for different services. And there is no free running period for urban and suburban services, and it's available in the mainline services. Generally, speed versus time. Speed versus time. Speed versus time. Now this one is the urban services. Now this one is the suburban. Now this is the mainline services. Okay, what is the difference between these two, urban and suburban services? Coasting period is longer in case of suburban services due to the distance between the stops is more as compared to the urban services. Okay. Okay, this is the mainline period. Now this is the acceleration period, coasting period, braking period, and there is no free running period. Similarly, acceleration period, coasting period, and braking period. Acceleration period, free running period, coasting period, and braking period. Now we can simplify the speed time curves. Now generally the speed time curve of suburban services can be replaced by an equivalent simplified quadrilateral shape. Okay, now like this. Now this is a quadrilateral. We can simplify the urban services, it will get the quadrilateral speed time curve. Similarly, this also will get the quadrilateral speed time curve. Okay, now this one is the speed time curve of mainline services is best and most easily replaced with a trapezoidal. Okay, now we'll get look like quadrilateral speed time curves. Now this one is the trapezoidal speed time curve. Now the total area, now this total area represents total distance traveled by the train, and the maximum speed indicates this is the Vm, this is the maximum speed of the train, Vm. Now this is the Vm. Okay, now since the area of the speed time curve represents the total distance traveled, and hence the areas of these two curves will be same. Okay, area will be same, that is total distance traveled by the train. Okay, first one is now trapezoidal speed time curve. First one is very important, trapezoidal speed time curve. Now here our main aim is to find out the maximum speed of the train. Okay. Okay, now our main aim is to find out the maximum speed of the train. It's compulsory question main exam lo, trapezoidal quadrilateral. Okay, now this is the speed in kilometer per hour, or we can say meters per second square. Okay, now here, now this is the time in seconds. So this one is t1, now this is t2, now this is t3. Now this is 0, A, B, T, E, C. Okay. Now this is the trapezoidal speed time curve. Okay. Now here D, capital D is the, not this one, capital D. Okay. Now capital D is the distance between stops, or distance, total distance traveled by the train. Okay. Distance between the stops or total distance traveled by the train in meters. I'm calculating in meters. Now T is the actual time of run. Actual time of run between stops. T is the actual time of run between the stops in seconds. Okay. Now alpha. Now alpha is the acceleration during the starting period. Acceleration during starting period. Alpha is the acceleration during the starting period. Now it comes from this acceleration period. First one is acceleration period, free running period, and braking period. Okay. Now alpha is comes from acceleration during the starting period. Now it is in meters per second square. Okay. Now beta. Now what is the beta? Retardation. Retardation during braking period. Now it is also meters per second square. Okay. Now Vm is the maximum speed or crest speed. Now this one, Vm. Okay. Maximum speed in meters per second, not square, meters per second. Okay. Vm is the maximum speed or crest speed in meters per second, and Va is the average speed in meters per second. And T1, what is the T1? Time of acceleration. T1 is the time of acceleration in seconds, and T2 is the time of free running period. Okay. Now T1 is the time of acceleration. Time of acceleration period. And T3, what is a T3? T3 is the time of braking period. Time of braking period. And T2 is the time of free running period. Okay. T1 is the time of acceleration period, T3 is the time of braking period, T2 is the time of free running period. So this is the trapezoidal speed time curve. Now it can be divided by 0 OED is the acceleration period, ABD E is the free running period, BCE is the braking period. Okay. Now D is the total distance traveled by the train, and T is the actual time of run between the stops in seconds, and alpha is the acceleration during starting period, and beta is the retardation during the braking period. Vm is the maximum speed, and Va is the average speed. Okay. Now alpha, what is the alpha? Well, alpha is nothing but a acceleration during the starting period. So it comes from acceleration period. Alpha is comes from this acceleration period. We can write alpha equals to, now this Vm by T1. Okay. Now we can write alpha equals to Vm by T1. Similarly, beta equals to Vm by T3. So alpha equals to Vm by T1, or we can write T1 equals to Vm by alpha. Okay. Now beta equals to Vm by T3, or we can write T3 equals to Vm by beta. Okay, now what is T2? We can write T2 equals to total time minus T1 plus T3. Okay, T1 equals to Vm by alpha, T3 equals to Vm by beta, and T2 equals to total time of run minus T1 plus T3. Okay, now our main aim is to find out the Vm. How to find out the Vm value? So first of all, what is a capital D? Capital D is nothing but a total distance traveled by the train. So capital D is the total distance traveled by the train. So total distance traveled by the train. Now we can write D equals to area. The total area is equals to total distance traveled by the train. Now the area of trapezoidal speed time curve. Okay, now capital D indicates the area of the trapezoidal curve. Now how to find out the area of the trapezoidal curve? Now this is the total area represents total distance traveled by the train. Okay, in this total distance traveled by the train we can find out the Vm value. ఓకే దాంట్లోంచి విఎం వచ్చేస్తుంది మనకు. సో ఎలా ఫైండ్ అవుట్ చేస్తాం ఈ ఏరియా అనేది? నో దిస్ టోటల్ ఏరియా కెన్ బి స్ప్లిట్ ఇన్ టు ద టీ పార్ట్స్. దిస్ వన్ పార్ట్ and this is another part and this one is another part. Now this look like a triangle. Now area of the triangle, if I can find out the area of the triangle, now place, now this is a rectangle or square. Okay, we can find out the area of the square or rectangular. Now this look like another triangle. Now find out the area of the triangle. Okay, we will get the total distance traveled by the train. So D equals to, now the area of OAD, the triangle period OAD. Now plus area of ABED plus area of BCE. Okay, now how to find out the triangle area? Half into length into breadth, that is equals to half into Vm into T1 here. So now the area of ABD, now we can write Vm into T2 plus another triangle half into Vm into T3. Okay, half into Vm into T1 plus Vm into T2 plus half into Vm into T3. Now we can write Vm common this there, T1 by 2 plus T2, or we can write substitute the T2 value here. Okay, now we can write half into Vm into T1 plus Vm into T2 value substitute చేద్దాం. T minus T1 plus T3 plus half into Vm into T3. Now we can Vm common this there, T1 by 2 plus T minus T1 minus T3 plus T3 by 2. So Vm అదిని సింప్లిఫై చేస్తే I will get half in T minus half into T1 plus T3. Okay, Vm into T minus half into T1 plus T3. Now we can write D equals to Vm into T minus Vm by 2. Okay, we can substitute T1 plus T3 values here. Okay, T1 equals to Vm by alpha plus T3 equals to Vm by beta. So Vm బయటకు వచ్చేస్తుంది Vm into T minus Vm by 2 1 by alpha plus 1 by beta. So 1 by alpha plus 1 by beta. Okay. Now let us assume 1 by 2 1 by alpha plus 1 by beta is equals to some constant k, or we can write alpha plus beta by 2 into alpha beta. Then LCM this way, we will get this one, that is equals to k value. Okay, alpha plus beta or by 2 into alpha beta. Now here 1 by 2 1 by alpha plus 1 by beta is nothing but a some constant k. Now substitute in this equation. Now d equals to Vm into T minus k into Vm. Okay. Now d equals to Vm into T minus k into Vm. Now దీన్ని ఇంకా సింప్లిఫై చేస్తే k into Vm square minus Vm into T plus d equals to 0. So we can write this one is equals to Vm equals to T plus or minus under root of T square minus 4k into D by 2k. Okay, now this is the maximum speed equation. T equals to Vm equals to T plus or minus under root of T square minus 4kd by 2k. Now the positive sign will not be used as it will give much higher values of maximum speed, okay, which will not be met in the practice. Therefore we can write Vm equals to T minus under root of T square minus 4 into k into d by 2 into k. Okay, పాజిటివ్ వాల్యూ ఎప్పుడు యూజ్ చేయొద్దు, ఎందుకంటే ఇట్స్ వాల్యూ అనేది ప్రాక్టికల్గా ఇంపాసిబుల్ వస్తుంది. దట్స్ వై వీఆర్ యూజింగ్ మైనస్. ఓకే, నౌ ఆల్సో వీ కెన్ రైట్, సపోజ్ ఈ ఈక్వేషన్ ఉంది కదా, ఇలా కూడా ఫైండ్ అవుట్ చేయొచ్చు. k ఇంటూ Vm స్క్వేర్ మైనస్ Vm ఇంటూ T ప్లస్ D ఈజ్ ఈక్వల్స్ టు 0. యూ కెన్ రైట్ Km ఇంటూ Vm స్క్వేర్ ఈక్వల్స్ టు Vm into T minus D. Okay, now K equals to T by Vm minus D by Vm square. Okay, now D by Vm square, now Vm into T by D minus 1. So now let us assume average speed equals to total distance traveled by the train by actual time of run. So we can write K equals to D by Vm square Vm by Va minus 1. Okay, k equals to d by Vm square Vm by Va యావరేజ్ స్పీడ్లో ఫైండ్ అవుట్ చేయాలి k వాల్యూ అనుకుంటే ఈ ఫార్ములా యూజ్ చేయాలి. ఓకే, మ్యాక్సిమం స్పీడ్ వచ్చేసి Vm ఈక్వల్స్ టు T మైనస్ under root of T square by 4kd by 2k, where T is the actual time of run, k is the constant. We will get value 1 by 2 into 1 by alpha plus Now this is the speed. Now this is the time. Now here the two speeds are there. Now the V1 and V2. Now our main aim is to find out here V1 and V2 values. Okay. In this case, we can find out the V1 and V2. Now 0 OAD. Now BEC. Now this is the T1, T2, now T3. Okay. Now alpha is the acceleration during the starting period. Acceleration during starting period. And beta is the retardation during braking period. Now here beta is C is the coasting retardation or retardation during the coasting period. Retardation during coasting period. Okay. Now V1 is the maximum speed. Maximum speed at the end of acceleration. At the end of acceleration period. And V2 is the speed at the end of coasting period. Speed at the end of coasting period. Okay, and T is the total time of run or actual time of run. Okay. Now this one is a, it's look like a triangle. Now this one is a, what is this one? It's look like a, what is this one? Tell me anybody. So here alpha is the acceleration during the starting period and beta is the retardation during the coasting period, and beta is the retardation during, beta C is the retardation during the coasting period, beta is the retardation during braking period, and V1 is the maximum speed at the end of acceleration period, and V2 is the end of the coasting period, and T1 is the time of acceleration period, T2 is the time of free running period, coasting period, and T3 is the time of braking period, and capital T is the total time of run. Similarly here also Vm T1 equals to Vm by alpha and T3 equals to Vm లేదు కదా T1 equals to V1 by alpha and T3 equals to V2 by beta, and T2 equals to V1 minus V2 by beta C. Okay. Now in this case theta 2 equals to V1 minus V2 by beta C. Okay. Now the total distance traveled by the train D equals to, now the area of OABC, that equals to area of OAD plus area of ABED plus area of BCE. Okay. Now the area of OAD equals to half into V1 into T1. Now the area of ABD equals to V1 plus V2 by 2 plus half into V2 into T3. Okay. Now half into V1 into T1 plus T2 plus half into V2 into T2 plus T3. We can write half into V1 into T1 plus T2 plus half into V2 T2 plus T3. Okay, now half into v1 into t1 plus t2 equals to, we can write t minus t3 plus half into vt into t2 plus t3 equals to t minus t1. Actually t1 plus t2 plus t3 equals to capital T కదా. ఓకే, దాని నుంచి ఈ ఈక్వేషన్ రాసాను. ఓకేనా, now we can write half into t into v1 plus v2 minus v2 into t1 by 2 minus v1 into t3 by 2. Now half into t v1 plus v2 minus half into v1 v2 t1 plus t3. t1 plus t3 లో we can directly write 1 by alpha v1 by alpha plus 1 by beta. v1 v2 బయటకు వచ్చేస్తుంది ఇక్కడ. ఓకే, half into v1 v2 1 by alpha plus 1 by beta. So we can write d equals to half into t v1 plus v2 minus half into v1 v2 1 by alpha plus 1 by beta. Now d equals to half into t v1 plus v2. Now half into 1 by alpha plus 1 by beta is nothing but a k value. So minus k into v1 v2. Okay, now is equation 1 అనుకుందాం. d equals to half into t, okay, v1 plus v2 minus k into v1 to v2. Okay, now we can write, now v2 equals to, ఇక్కడ తీసుకుని నెక్స్ట్ పేజ్ తీసుకున్నాం. So we can write beta c equals to v1 minus v2 by t2, or t2 equals to v1 minus v2 by beta c. Now from this equation we can write v2 equals to v1 minus beta c into t2. So v1 minus beta c into t2 is nothing but a t minus t1 minus t3. That equals to v1 minus beta c into t minus t1 is the v1 by alpha minus t3 is the v2 by beta. So v2 equals to, okay, v1 minus beta c, can write t minus v1 by alpha plus beta c into beta. So v2 into 1 minus beta c by beta is equals to v1 minus beta c into t minus v1 by alpha. Okay, now we can write v2 equals to v1 minus beta c into t minus v1 by alpha by 1 minus beta c into b. Okay, now v2 equals to v1 minus beta c into t minus v1 by alpha by 1 minus beta c by beta. Now beta c is the retardation at the end of the coasting period, and v1 is the maximum speed at the end of acceleration period, and alpha equals to acceleration period, beta is the retardation during the braking period. Okay, ఇవన్నీ values ఇస్తాడు. So we can find out the v2 value. v1 ఇస్తాడు, beta c ఇస్తాడు, t ఇస్తాడు, అన్ని ఇస్తాడు, v2 value find out చేయమంటాడు. Okay, now this is the trapezoidal and quadrilateral speed temp curves. Okay, మీకు గుర్తుందా ఇది? నేను లాస్ట్ క్లాస్లో చెప్పాను, వాట్ ఈజ్ ది యావరేజ్ స్పీడ్, వాట్ ఈజ్ ది క్రెస్ట్ స్పీడ్. అవి కూడా వెరీ వెరీ ఇంపార్టెంట్. ఇప్పుడు మనం చేసే ప్రాబ్లంలో అవి కూడా యూజ్ అవుతాయి. సో వాట్ ఈజ్ ది క్రెస్ట్ స్పీడ్? Crest speed is nothing but a maximum speed attained by the train. Maximum speed attained by the train is called crest speed. And second one is average speed. Average speed nothing but it's represented with VA. VA equals to total distance traveled by the train plus actual time of run. Okay, and third one is scheduled speed. Scheduled speed represented with VS. VS equals to total distance traveled by the train, total time of run plus time of stop. Okay, now this is the formulas. 1 second. Okay, ma. Okay. Now the difference between the three services: mainline services, suburban services, and urban services. Now the distance between the stops in kilometers. Now it's a mainline service is more than 10 kilometers. Suburban services is 1 to 8. urban service is 1 kilometer. And the maximum speed in kilometers per hour, main line service is 160 and urban services is 120. Suburban services 120, urban services 120. And the acceleration values are mainline services 0.5 to 0.9, suburban services 1.5 to 4, urban services 1.54. Now retardation in mainline services 1.5, suburban is 3 to 4, urban is 3 to 4. Now features of mainline services is long free running period, coasting and acceleration periods are small. And suburban services no free running period, coasting period is long, and urban services no free running period, coasting period is small as compared to suburban services. And the different terms are used for speed: crest speed, average speed, and scheduled speed. Now crest speed is nothing but it is a maximum speed. Now average speed is equals to total distance traveled by the train or distance between the stops by time of run. Now the scheduled speed is equals to distance between the stops by time of run plus time of stop. So generally the speeds are in kilometers per hour. Now VA equals to D by T. Okay, total distance traveled by the train by time of run. So we can write average speed is equals to 3600 into D by T. Okay. ఎందుకంటే velocity and accelerations are given in kilometers per hour and kilometers per hours per second. Okay, velocity and acceleration are given in kilometers per hour and kilometers per hour per second. Units may be converted into meters per second and meters per second square. That's why we are multiplying with 3600. Okay, similarly scheduled speed is also d by t plus ts kada akkada into 3600. Okay, now the average speed is always greater than the scheduled speed for urban and suburban services, and mainline services VA value is equals to VS. The factors affecting the scheduled speed is the crest speed, the duration of stops, the distance between the stops, acceleration and braking retardation. So one problem with them, the average speed and the scheduled speed of a train are 36 kilometers per hour and 30 kilometers per hour respectively. If the distance between the stops is 1 kilometer, calculate the time of run and time of stop. Okay, VA value ఇచ్చాడు, average speed 36 kilometers per hour, VS ఇచ్చాడు, scheduled speed 30 kilometers per hour, and the capital D value ఇచ్చాడు, total distance traveled by the train or distance between the stops is equals to 1 kilometer. Okay, now VA time of run అడుగుతున్నాడు, time of stop. సో time of run plus time of stop ఎక్కడి నుంచి వస్తుంది అంటే time of run మనకు యావరేజ్ స్పీడ్ నుంచి ఫైండ్ అవుట్ చేయొచ్చు. యావరేజ్ స్పీడ్ ఈజ్ ఈక్వల్స్ టు 3600 ఇంటూ డిస్టెన్స్ బిట్వీన్ ద స్టాప్స్ బై టైమ్ ఆఫ్ రన్. ఓకే, యావరేజ్ స్పీడ్ వాల్యూ ఇచ్చాడు, 3600 ఉంది, మనకు డిస్టెన్స్ బిట్వీన్ ద స్టాప్స్ ఉంది, ఈ టైమ్ ఆఫ్ రన్ వాల్యూ ఫైండ్ అవుట్ చేయాలి. సో యావరేజ్ స్పీడ్ ఈజ్ ఈక్వల్స్ టు 3600 ఇంటూ డి బై టిఆర్. సో VA వాల్యూ 36 ఇచ్చాడు, 3600 ఇంటూ డి వాల్యూ బై టిఆర్. ఓకే, టిఆర్ వాల్యూ ఇక్కడ తీసుకొస్తే 3600 ఇంటూ డి వాల్యూ 1 కిలోమీటర్ ఇచ్చాడు, 1 బై 36. ఓకే, టిఆర్ వాల్యూ టైమ్ ఆఫ్ రన్ ఈజ్ ఈక్వల్స్ టు 100 seconds. Similarly, scheduled speed is equals to 3600 into distance between the stops by time of run plus time of stop. సో ఈ వాల్యూ టైమ్ ఆఫ్ స్టాప్ వాల్యూ ఫైండ్ అవుట్ చేయమంటున్నాడు మనకు. ఓకే, VS ఈక్వల్స్ టు 3600 ఇంటూ డి బై టైమ్ ఆఫ్ రన్ ప్లస్ టైమ్ ఆఫ్ స్టాప్ కిలోమీటర్స్ పర్ అవర్. సో VS వాల్యూ 30 ఇచ్చాడు, 30 కిలోమీటర్స్ పర్ అవర్ ఈజ్ ఈక్వల్స్ టు 3600 ఇంటూ డి వాల్యూ 1 బై టిఆర్ వాల్యూ ఇంతకుముందు ఫైండ్ అవుట్ చేస్తాం కదా 100 seconds ప్లస్ టిఎస్. సో దీన్ని డిస్కస్ చేసేయండి.
Now 100 plus TS is equals to 3600 into 1 by 30. So 100 plus TS is equals to this value 120. So TS equals to this 120 minus 100, that is equals to 20 seconds. ఇలాంటి ప్రాబ్లం ఒకటి కంపల్సరీ వస్తుంది, టైమ్ ఆఫ్ రన్. ఓకే, సో నెక్స్ట్ క్లాస్లో ట్రెపిజాయిడల్ స్పీడ్ టైం కర్వ్, కోఆర్డినేటర్ స్పీడ్ టైం కర్వ్ మీద ప్రాబ్లమ్స్ చూద్దాం. కానీ అటెండెన్స్ అందరు చాట్ బాక్స్లో పెట్టేసేయండి. రా వైష్ణవ్ మేడం, హెచ్ఓడి మేడం రాగానే ఇచ్చేస్తాం మీకు. హెచ్ఓడి మేడం రాగానే సైన్ చేసి ఇచ్చేస్తాం.